Hello guys. So today we'll see next question in LeetCode 75 series. So let's start. Let me take you to the screen. Yeah. Then now, uh, the question is move zeros. What the question says that given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Basically, it means we have to keep non-zero elements in that order only, but they should be on the left and all zeros should be on the right. So yeah, let's take this example and the answer itself. So the answer we can get that 1 3 and 12, like this was the original array, and we have this the after performing move zero function, what the nums array become, that this all the non-zero element 1 3 and 12 shifted to the left and all 0 shifted to the right. That's what we have to do. So yeah, first approach coming in my mind is using another data structure. We can use another data structure like vector itself, and first we will put all the non-zero element in that, and after that, if its less size, till its size becomes like not like it's not equal to nums dot size, that original size, till then we add 0 in that, and we'll copy that numbers to the nums. That's the first approach, that's the name approach basically. And the second approach coming in my mind is we'll count number of zeros, and then we'll count number of zeros, then we will do one thing ki we'll traverse from left, and we'll take two pointers left and right. We'll traverse from left, and all the non-zero numbers, 1 minute, think I have to start it again. Yeah, yeah, now yeah, then the approaches we need to take left and right and copy right element to the left if the left is 0 and right is not 0, and then increment the left pointer and increment the right pointer. Likewise we will do, and after that, whatever the numbers remain, like uh, left and right, after like left will be the our last point where total number of non-zero numbers will end, and after that we'll copy all the like count number of zeros that we will copy. That these two approaches, and one approach using without counting zero is also there. Like we'll take left and right pointer only, and we'll copy all the elements to the right to the left pointer, and likewise we'll maintain sequence also. Let me explain you optimal approach, then we'll see all three code of all three approach. It's simple. Yeah, what the most like optimal approach that coming in my mind, that take L pointer and take the right pointer. If L pointer is 0, then don't increment it, and for right pointer always increment it. Like yeah, we'll increase the right pointer at every step, like while traversing at every step we'll increase the right pointer, and if it's 0 we'll increase it, if it's non-zero we'll copy it to the left and we'll also increase it. Okay, now we'll increase the right pointer. Now here r first L and R0, that it was here, and if now uh, nums at L was 0, so I didn't increment the L, but nums at I incremented the R. Now nums at R is not equal to 0 and copy it to the L, and when I copy it, then it becomes 1 and it becomes 0. Like I will swap it basically, and I will increase the L. Now my L is here. Let me do one thing. What? Okay, okay. Keep it as it is. L and R, and I will increase the R. Now R is 0, so I won't swap it. Then I'll go ahead like and I see there is 3 on the R pointer, so I'll swap it again. And after swapping it, what happens? After swapping it to the L, it becomes 3 here, and it becomes 0 as I'm swapping it. So it will be 0 as it is, and it will become also 0, and my L pointer will shift to this, and my R pointer also will shift like one pointer, like one step ahead. It is 12 now, and swap it, it's non-zero, so we'll swap it to L, and it becomes 12 here, and it becomes 0. So it becomes 12 and it becomes 0, and again increase the L pointer. Yeah, that's how we'll do until the R is equals to n, that is nums dot size. This is the optimal approach that coming in our mind. Okay, so we'll see first naive approach, then we'll see optimal approach and all the approaches. So naive approach is take a vector in. I think you will do what is the naive approach. Just I'm writing it, and you will code it. Like I believe it's it's so basic, and we'll do it basic approach, or we can say brute force to this, because it require extra space complexity, and the optimal approach don't require any extra space complexity. So basic approach, what we will do, extra space, and copy all copy all non-zero element, and yeah, copy extra space, or we can say copy extra space means what extra space do we require? That vector of size n, nums dot size, and we'll initiate it all 0, like this vector in, and result will be n zeros, and we'll copy all non-zero element to the left, and we'll copy our result vector to nums, to original vector basically. And that's how the basic approach will work, and we'll code the optimal approach. For the optimal approach, we'll code it. Let's see. I wrote the algorithm for this, and now we'll write the code for the optimal approach. What the optimal approach says, that will require L 0 and R 0. Like will require 2 pointers. Will require nums dot size. I'll store it in n, and while my right pointer is less than n, what I will do, if my nums at L is equals to 0 and nums at R not equal to 0, then swap it. Swap nums at L and nums at R and L plus plus. Otherwise, just we'll increment the R at each step, but we'll increment the L when we'll get the R, nums at R is not equal to 0 and nums at L is equal to 0. What if nums at L is not equal to 0? At that point, what we will do? Like, that's the coming in my mind, that if we'll skip it, and what we will say, if my nums at L is not equal to 0, then increment it. Like what I was thinking, I have nums array. I have nums array like this: 1, 2, 3, 0, 0, again 1, 2, 3. In this case, what I have to do, all this 2 0 need to shift at right. Let's dry run. I have L and I have R at is equals to 0 and R, and yeah, this is all new. I'll go in row while R is less than L. If L is not equal to 0, then L plus plus, that L will go here. R plus plus will happen at every point, R plus plus. And Then again I will go to the next loop. At that time L is not equal to 0, I'll plus, then R is also plus. Then at that point, again at this L is not equal to 0, I'll plus it, then I'll go for the right pointer, it will also will plus, and then what I can see key nums at L is equal to 0, so L won't be will won't increment the L but will increment R. Then we again increment the R, then we can see L is equal to 0 but R is not equal to 0, so we'll swap it. So here it becomes 1 and it becomes 0, and as it is not equal to 0, L will be plus plus, and then R is always like incrementing, we are incrementing the R at every step, so it will go further, and we have this 2 and it is also 0, so again we will swap it 2 and this will be 0. Then again we will go ahead and this will also will go ahead, and this is 3 and we'll swap it. Here it will be 3 and it will be 0. So likewise we have maintained the order, and yeah, I think it works. So sub let's run it first and we'll see what happens. Okay, then submit it. Yeah, it passes all the test case, and yeah, we have nice like 100% we beats the all solutions. And we have the time complexity for this is time complexity is big of n basically, because we are traversing the nums, and like we are just traversing array one time, so it's big of n. And space complexity, we didn't use any extra space complexity, but we have used this. Basically, we have used these two variables, so we can take its space complexity is constant, that big of 1. So yeah, this is the solution. Now, uh, yeah, bye.